Hi, in this lecture we are going to know about the number systems, what are the various number systems and how to represent the numbers in different ways. Before we get into what exactly knowing about the number systems, let me explain you something else we daily see in our daily life, that is about the clock. And we know that a clock is going to have three specific things. It's going to have the hours, it's going to have the minute section, and it's going to have the second sections. This is the seconds position, and this is the minutes, and this is going to be our hours. Yes, and basically all of them starts with the minimum value as 0 seconds and 0 minutes and 0 hours. And once the timer starts up, the seconds gets increased first. Starting up, the next second is going to be 1, and so on. It increases up, so on, up to 59th second. So the minimum value is 0 and the maximum value is 59. If it encounters the 60th second, so it resets its position to 0 because its maximum values it can store is only 59. And 60 it cannot accommodate, it resets its position to the basic value 0 again, and the extra value that we have got is going to be taken into consideration as 1 minute. Okay, in the same manner the minutes section also gets incremented, okay, for every 60 seconds. It takes the maximum value up to 59, that is 59 minutes. Once it encounters the 60 minutes, it resets its position back to 0 once again. And the extra value that we have got is going to be taken as a carry to the hours, that is 1 hour. So even the hours position is going to get incremented to the maximity value of 23, and once it encounters the 24th hour, it's going to reset its position to zeros. That is, you can see the entire clocks get resetted to the basic value. This is what we see in our daily life. And what is the special thing that we look into this? We can understand that seconds place takes the minimum value as 0 and the maximum is 59. So total of 60 values, that is 60 symbols or 60 digits that is going to consider. So we call seconds takes the base 60 system. And minutes also takes 60 base system, that is it is going to have 60 numbers or 60 digits that is going to consider in order to represent minutes. Whereas hours are going to take 24 as the maximum value, that is for 24 digits or 24 bits in order to represent. So we can say its hours follow a 24 base number system. Let us know what exactly number systems and how we are going to use. A number system is a mathematical notation for representing the numbers of a given set using the digits or the symbols in a consistent manner, as we did now in the clock, in order to count our time. We basically have 4 number systems, that is the decimal number system, binary number system, octal and hexadecimal number systems. Let us look into decimal number system. Deci means 10, that is it is going to contain 10 symbols or 10 digits, we can specifically say. Those 10 digits are going to be from 0 to 9. So as there are 10 digits, we call them as base 10 system or decimal system. So this particular thing, as time, seconds use 60 values and minutes used 60 values, 60 numbers, and hours use 24 numbers. In the same manner, the decimal numbers are going to use 10 numbers or 10 digits, okay, in order to write the values. So they start from 0 as the minimum value, and 0 plus 1 it goes to 1, and 1 plus 1 it goes to 2, and so on. Its values get to the maximity of 9. So once if it is 9 plus 1, that is the next number that I wanted to represent, it has to reset its basic value to 0, that is it resets its 1, and the extra carry that has occurred is going to take it as 10, that is we call it as generally as 10. So the next one, 10 plus 1, that is 0 plus 1 becomes 1, so that is 11, 12, and this part is going to get added up, so on up to 19. So 19 is the maximity. So once it is, we have to represent 19 plus 1. So 9 plus 1 is going to cannot be accommodated. So 9 is going to reset its position to 0. 1 is carried out to this one. So 1 plus 1 becomes 20. So this is how we are going to represent the decimal numbers. So the maximity of two digits are going to be 99. 99 is the values, and once it is 99 plus 1, that is the next value, 9 cannot be accommodated. It resets its position 0 and carries the next value to 9. So 9 plus 1 is again a maximity, so reset its position to 0 and 1 is going to get carried out. So this is how we are going to represent decimal numbers. Let us see a few of the examples. These are the numbers that we can consider, and we are going to notate these numbers, okay, with the entire number represented in the parenthesis with a subscript of 10, that is it's 10, okay, which indicates that this is a decimal number system. Now let us look into the binary number system. Bi means it's 2, that is it's going to contain only two symbols or two digits that we are going to use. They are going to be 0 and 1, so we call it as a base 2 system or else a binary number system. So we represent the numbers, the minimum value is going to be 0 and 0 plus 1 is going to be 1. So these are the only two values to consider. So 1 plus 1 we cannot accommodate because we have to use only these two digits. So if it is 1 plus 1, that is the next digit has to be represented. It is going to take resets its position to 0 and the carry is going to be forwarded onto the left hand side. So this is the representation of 1 plus 1, that is 2. So 2 is represented in binary as 1 0. So if I wanted to represent 0 3, then it is nothing but 2 plus 1, that is 1 0 plus 1, that is 0 plus 1 is going to be 1 and is going to be 1 itself. So if I want to take it into consideration of 1 4, so here it's nothing but 1 plus 1, which is not possible, so it has to reset its clock to 0 and the 1 is carried up to the next value. So it is 1 plus 1, it becomes again, it resets the position to 0 and it is carried forward. So 4 is represented as 1 0 0. This is how we are going to represent the binary values. Let us take few examples. So every number in binary system are going to be present only in zeros and ones, and we notate these values within the parenthesis. The digit is going to be written with subscripted with 2. And if we consider the next system is going to be octal. Octal means 8, that is it is going to use or contain 8 symbols. 8 symbols in the sense it is nothing but from 0 to 7. So we call it as a base 8 system or else an octal number system. So the minimum value is going to start at 0 plus 1 is going to be 1 and so on, it goes on up to 7. And if I want to notate 7 plus 1, which is the next value, so it's not possible, so it is going to reset its position to 0. The carry that we got is going to take as 1. So this value represents actually 8. This is the decimal number 8. The decimal 8 number 8 is going to be represented as 10 in octal system. So this is how we are going to represent. Let us consider a couple of examples. This is how, and we are going to notate the digits written within the parenthesis and subscripted with 8. The next we have is the hexadecimal number system. Hexa means 16, that is it is going to contain 16 symbols. 16 symbols in the sense 0 to 15. We already know 0 to 9. Okay, next is going to be 10, 11, 12, 13 up to 15. But they are going to have certain symbols in notation. That is 0 to 9 is same as in the decimal part. 10 is going to take the occupation of position A. 11 is considered as B. 12 is considered as C. And 13 occupies the position of D. And 14 as E. And 15 is F. So these are the different position values. So 0 to F. So we call it as a base 16 system or a hexadecimal number system. A few of the examples in this system are going to be in this manner. A combination of alphabets and numbers, or only numbers, or completely with alphabets. But the alphabets should be only from A to F itself. So the notation could be like within the parenthesis we write the digit or the number and subscripted with 16. So this is how we are going to represent the different numbers. Let me give you a few examples. In order to check whether a specific number is a valid number or not. For example, if I have written something like 1 2, 1 2 is a number which can be a base 8 system. Yes, it's possible. And 1 2 even can be taken into consideration as a base 10, that is a decimal value. Yes, it is possible. And 1 2 even can be considered as a base 16 system because these digits are present. But whereas 1 2 is not a valid binary system because 2 is not present, so it is not going to be considered. So whatever the numbers we form in the respective number systems, it should contain the respective symbols. So for example, I wrote 1G and A, okay, and I wrote it as the base of 16. 1 is present in the hexadecimal system, A is present, but G is an invalid thing, so this cannot be considered as a valid hexadecimal value. So we have to take care of whenever we are going to write any of these number system values. Number system conversions is the next lecture that we are going to see in the next lecture.